Okay, we selected our finite element model. We say fine. Now there's a couple of things we have to do. Is first of all the procedure. First step is we go to procedure static. This is step one, which is the shrink fit step, and I'm going to give an initial time increment of 0.1. Okay, let me hide the mesh. Good. So why don't we actually apply the restraint on this face, which is going to be clamped? So it's going to be a boundary condition, fixed displacement on that, and I will say fixed end of the tube. Fixed. How about calling it outer outer fixity? Fixity. It's outer tube basically. That's what I mean. X, Y, Z, and all three are fixed. Okay, good. Now this face is going to be in the first in the step one. Is going to be also fixed in X, Z, and Y, X, Y, Z. However, I'll do that. I want to do that separately. So this one is going to be inner X and Z, X and Z. Okay, and that is the face, and X and Z are fixed. And I'll do another one, but this one I'll call it inner Y, and I'm just going to fix the Y. On purpose, I did these separately. Okay. So the reason I'm naming these things is that later on I know exactly what is it referring to. Okay. Now we also have to fix that the reference point. So we're going to do a fixed displacement. So I'll say reference point. Reference point. Call it like that. Reference. Okay. Reference point in the direction Y. Now for the support, I'm going to get it from the tree. So under engineering connections, see if we can find a expand this thing in the free. I can select this coupling and does not move in direction Y. Now remember I said that there's no need for me to go and do Y both rotation and translation, although I did it in tutorial 4 and 5. You say okay. All right. Yes, that's pretty much it. So now we're going to create our interactions. So interaction, first define a contact property, and that's going to be contact property 1, okay? The friction specified as 0.1, okay? All right. And now we're going to do define them, surface-based contact, okay? So this first one, I'm going to call it for the shrink fit purpose. I'll call this thing uh, whole of the C clamp and inner tube basically. So for the main, I'm going to select the surface of the inner tube, and for the secondary, I'm going to select the surface of the inner hole of the C clamp. So let me hide that. That's going to be our uh, secondary surface, the hole. And then for contact property, we're going to use contact property 1, and we say OK. This is going to be later on using my shrink fit is going to be using this. As a matter of fact, now that we have done it, we might as well go ahead and do the shrink fit right now. So there's the contact interference. That is the surface. This is the surface-based contact that are created right there. We select it and we say OK. Now, I also have to make sure that this guy later on does not penetrate that. So I'm going to do another surface-based contact. Let me see now. So for this, I will call it uh, outer tube and outer C-clamp. These are the vertical faces. What vertical faces? Vertical faces. Okay. And so for the primary, I'm going to select the surface of this outer tube, and for the secondary, I'm going to select the surface of this C-clamp, and the contact property 1. And I want to do another one between this face and the face of that uh, inner tube that's in hiding. So let's get this thing. Try it. Okay, so let's go back here. Okay, so let's see now for another one. I'm going to call this thing inner C-clamp, and these are vertical face. Okay, so for the main, I'm going to select the face of the outer tube, and for the secondary, I'm going to select the face of that C-clamp and contact property 1. Say OK. Good. Okay, so that takes care of these. Uh, if I run this thing, assuming that I didn't forget anything, it's going to give you the shrink fit of that C-clamp onto the shaft. So let's go ahead and check it out. First of all, let's save this. Okay, so we go simulate. Here is the model check. No problem. Here is the simulation check. I don't anticipate any problems. Okay, that's almost done. And then we're going to run it or simulate. So this outer tube, which is, basically that yellow piece, doesn't do anything because there is nothing that comes from the shrink fit right now. And just wait for it to finish. Here's the iterations, which is the equivalent of your monitor in the Abacus CAE. All right. You can see that it's going very quickly. It just finished. And all we're going to see is the shrink fit result. Okay, so close this. This is step 1. Initial step, of course, initial step, there's nothing there, but at the very end, there's the shrink fit result. Okay, good. And then we're going to go back to scenario. and we're going to push this thing to the right by 20 millimeters. Okay, so that this C-clamp barely establishes contact with that face, okay, face of the yellow piece. So we're going to go to procedure, another one, and I'm going to call this thing point one. Once again, give it point one initial. You say okay. All right. So we're in step two. So a couple of things, we're going to translate this thing to the right. But of course, remember, if you're translating this to the right, we cannot fix this face. We have to correct that later on. So we're going to go to boundary condition. Here is the translation, right translation. We translate this in the direction y by 20 millimeters, 20 mm. We say okay. Now, if you right click and say feature manager, it gives you the whole picture. What do I mean by the whole picture? This is what you did in step one. This is what you're doing in step two. Step two, one of the things that we're doing is we're translating it by 20 millimeter, which must be, sorry, apply translation 20 millimeter. But if you're going to do that, then you cannot fix those faces. For example, you cannot take the inner face and fix it in the Y direction. This is why I did this thing separately. I'm going to say right click, sorry, in the second step, right click, remove that. So let it go in the Y direction. And also there was a coupling somewhere, that reference point, which I called here reference point. This, it should also be allowed to uh, it should also be allowed to move. So I don't want this thing to be fixed in the Y direction. Right click, remove reference point in Y direction, fixity. Okay, so now we can actually push it, translate it. Okay, so that shouldn't be any problem anymore. Let's go ahead and do this. So let's do a model check. I don't anticipate any problem. Again, scenario check. I don't anticipate any problem. And finally, the run for step two. So nothing exciting is going to happen in step two. The whole thing, the shaft, inner shaft, and the C clamp are going to translate to the right by 20 millimeters. So say okay and then run it. There's the run. So far we're doing the checks, model check and scenario check. Okay, let's check the iteration tab. This will repeat both step one and step two. Okay, so of course the step one was already done, but there's no way around it as far as I know, unless you create restart files and things of that type, which we don't want to do that. Okay, this what you see here is step one, which is going to be fairly fast. Repetition of what you already saw. And then once it passes after 1 second, because 1.1, 1.2, etc., that becomes step two. By the way, this is real time that you're seeing, so it gives you an idea how fast these things, based on wall clock, are running. Almost done. It's just merely a translation to the right. When this ring reaches 2, it's going to be the end of step 2. In other words, translation is completed. C clamp is barely touching the inner tube, the outer tube. Yeah. And it's there. Okay, so let me close that. Let me close this. So this is step one, the end of step one, end of step one. You go to step two, notice that it reached, this whole thing was translated to the right by 20 millimeter, and it's just barely touching there. Okay, good. Let's do a quick save here and go and insert our step three. So, okay, so scenario, another step, procedure, static step three, and let me change the time here, initial time 0.1. You say okay. So remember, this translation should go now, and we will make it go, but I will show you through that table how to do it. It is also possible to do it through the tree, but that's okay. So let's see now, pressure, load, okay, load, pressure on that face, 100 MPa, say okay. So we're almost done, except that we have to get rid of some of these things. This translation should go, for example. We have the fixity here in X and Z should go. So right click, feature manager. We are dealing with the step three. That fixity, inner XZ was fixed, remember that? It should not be there because we are applying a pressure on it. There's no reason why it should not move in the X and Z direction. So remove in step three, and the translation. The translation, apply translation, 20 millimeter. This should also go. Right click, remove, okay, and that's pretty much it. This is the pressure that we just applied. Let's do a quick model check. Done. Scenario check. To some of us, these may be redundant, but it's always a good idea to spend an extra minute or so to make sure there are no serious errors. That's done. Almost. Okay, now it's done. Okay, and finally make a run. There's the run. There's a simulate. It's very easy to miss stuff here, so hopefully I didn't forget anything. Particularly what the restraints should go, what things should be added, etc. Those can be problematic. So unfortunately, it's going to do step one, step two, and step three, all of them again. Oh, three is new, but one and two are already done. This is going through the step one, which is the interference shrink fit or interference fit. And now it's going to go into step two, which is translation to the right. And finally, when it reaches at the very right overlap, then we're going to apply pressure. Of course, the C-clamp is going to push on the outer tube, it's going to push on the inner tube, so there's going to be interaction, contact interaction all over. So now we're going to step 3. This is the new piece. From time 2 to 3 is going to be step 3. Yep. Going very fast. Okay, almost done. Halfway through. Now notice that this is where the serious stuff is going to take place. That's why it's taking longer too, because you're pushing on they're pushing on the inner tube, you're pushing on the outer tube, the shrink fit, everything is playing role in the shrink fit phase. Step 1, it was just a shrink fit. In the translation, there's just translating, okay? But now there is contact interaction between vertical faces, etc. So that's why it's taking a bit longer. But it's almost done. Okay, it finished. Let's go ahead and check our work. Okay, close. Let me close that. Okay, so first of all, here is the shrink fit stage. This is at the end of the shrink fit stage. Then we're going to go step 2 after this thing translated to the right. Okay, still no stresses in this because it's not pushing on it. Step 3 is when the pushing begins by the pressure. There, you can see that. Okay, so you might say, all right, well, how do I know that actually there is a stress here? Well, first of all, if you put the cursor there, you can see that you can read some of these numbers. But there's a way that you can get your things organized. So let's go here. Okay, you put the cursor there. You put the cursor there, and there is this icon here. It says display group. Just get out of the way. You want to add a group. Group number 2. You say OK. And then close it right there, the check mark here. You can go to your display group 2 that you created. Okay, right there, double click on it. Do I want all the parts in it? No, I just want for example, the C clamp. Okay, and I want to replace whatever is there with just the C clamp stuff. There we are. Now you can see that actually there is a stress has developed in the C clamp because this is being pushed on it. The inner tube is pushing on this thing, and on this side it is actually confined by the outer tube. Okay, so that kind of finished our tutorial. I'm gonna, instead of appending this to the other piece, namely the creation of the parts and assembly and the mesh, I'm going to do this thing. It's going to become a long tutorial, a long video, so I'm going to split it into 2 parts, part 1 and part 2. All right, and good luck. This is extremely important. See that? If you click, get rid of this. If you click on this, this gives you the model, stuff on the model. This gives you stuff on the the loads, what goes, what propagates, what does not, etc. Very important. And this gives you information about the plots that you have generated. This is the one that you should be very careful about because uh, it can make or break, basically. Yeah. Good luck, folks.